Before to start this video, I want to talk with you about 3 reasons and why we should use NumPy. The first reason is because when you have to run a massive code, when you will have to manage different shares, different imports, different exports, your code can take a while to run, mainly if you have to run a loop with 500 shares, for instance. Your loop can take 1 hour, 2 hours, 3 hours. Sometimes in my code, when you are doing machine learning, for instance, that's not the purpose of this class. But let's say you're running a machine learning and deep learning model. Sometimes you can take 5-6 hours to run your model. The purpose to use NumPy is because you are going to use less memory, which means that your code is going to be much more efficient. Sometimes, just by using NumPy, you can drop the time to run your code by 20. You can make a test by yourself if you want, just time a very long loop by using NumPy or using the list with Python. You will see a huge difference. On top of using less memory, NumPy is more convenient as well for mathematical operation. For instance, if you want to multiply matrices, if you want to make different vector operations, or there is like a complete range of opportunities by using NumPy in order to gain efficiency in your code and to gain time. And the last point is the functionality. NumPy can be used with pandas, with multiple APIs, and the number of functionality of NumPy is limitless. And here are the 3 reasons why you should learn and use NumPy library. Let's go with the crash course. Let's start by importing our NumPy packages. We are going to type import NumPy as np. Let's execute. Now you just have uploaded NumPy package. Once you have imported your package, we are going to create our first list of values. Let's start. The list we are going to call this list A. In this list we are going to start the values 5, 6, 7, 8, 9, 10. Or like if you wish to use 1, 2, 3, 4, 5, that's fine. Let's execute this list. For now, we just have a list. If you want to have this list as a NumPy array, you have to type np array and include list A inside the parentheses. Now you have a NumPy array, as you can see here. But the point by doing that, you are not storing this list in a NumPy array. If we type list A, you will see that that's still a list. Exactly like before that we have converted it as a NumPy array. We have a list. What we want it as a NumPy array. In order to do so, you have to store this list in a variable that we are going to call R, for instance, like array, and copy and paste your NumPy conversion. Essentially what we are going to do here is converting this list as a NumPy array and storing it in this variable. And let's print it. Okay, we have an array. And now, if we check out the type of this variable, you will see that that's a NumPy array. Well done. You have just created your first NumPy array. And that's what I was explaining before this class when I was talking about the advantage of NumPy, is you can use Python list, but when using NumPy array, everything gonna be easier. You're gonna make your life easier. even for mathematical operation, for efficiency, like the number of arguments is limitless. You must use NumPy in your daily life. Okay, now we just have created your first NumPy array. 5, 6, 7, 8, 9, 10. That's easy for now. Now, let's check out the first option that we can have with NumPy is the function arrange. The advantage of the function arrange, spelling mistakes. The advantage of the function arrange is the fact that you can create an array, by defining your steps. Let me go further. What we are going to do here is, like, let's say we are going to create an array that we are going to call array 1, for instance, or just like array. And in this array, we are going to call NumPy and call the function arrange. And between the parentheses, if you do Shift plus Tab, you can have more information about it. As you can see, you have 3 arguments. The first one is the starting point, the second one is the stop point, and the third argument is the type, but that's optional. It's by default defined to none. What we are going here, which means that we are going to start by a start and a stop. And after that, we are going to print our array. Let's execute. Well done. You have your NumPy array between 0 and 10. As you can see, 10 is always excluded. Let's continue with another option with NumPy arrange. We are going to keep the name array, and inside it what we are going to use is the third argument. If you look at it, dtype is set up to none. The third argument is a step. The first one is start, the second one is stop, and third argument is the step. Here what we are going to do is to use a step of 3, for instance, or you can use a step of 4. Let's say we are going to use a step 4 and execute. As you can see, that will use 0 as a start point and going to raise each value between 0 and 10 with step 4, which means 0, 4, 8. If you use a step of 2, for instance, you will get 0, 2, 4, 6, 8, but 10 will always be excluded. If you want to include 10, you have to use one number above, and now 10 is included. Okay, let's continue. Right here you have seen the main function, the first function for NumPy, which is the function arrange. Another opportunity that you can use with NumPy is if you want to create a matrix composed by 0 and 1s. In order to do so, you will have to use a function which is called np0s and np1s. Let's call it module 0, 1, or like, yeah, np0, np1, otherwise it's gonna be good as well. Okay, let's set up a first list of a first size that we are going to set up as 7.3. You will understand afterwards why I'm setting this list 7.3 in this variable size. Let's execute. What you are going to do here, you are going to create your first matrix composed by 0 of 1s. Okay, let's start with 1. That's gonna be a little bit different as usual. We are going to create this matrix. We are going to type np1s and between parentheses we are going to insert the size of the matrix and print the matrix afterwards. Execute. Okay, now what you have just done right now, you have created a matrix with the size 7, 3, which means you have 7 rows and 3 columns. Always remember that these numbers represent the number of rows and this number represents the number of columns. I'm going probably to ask you this question during the quiz. Just keep it in mind. Let's continue. Now that you have printed your matrix, you can also have the opportunity to use the print function if you want to remove this data type. If you do that, okay. And otherwise, if you don't want to use size, you can just like directly include your list of value inside it, and that will work. If you want 5 by 3, execute, that works as well. Now you can do the same with a matrix composed by zeros, but instead of ones you have to type zeros. We are going to call a matrix 4 by 2. Let's execute. Yeah, you have your matrix 4 by 2 composed by zeros, as you define here. Okay, that's all for this second possibilities with NumPy. Now that we have seen two basic functions with NumPy, which are the function arrange and the function np01, we are going to create a new and we are going to use a new function which is random matrix. In order to do so, let's add a new title that we are going to type random matrix. And we are going to explore how we can create a matrix composed by random number. You can need this type of matrix at any time. For instance, if you want to shuffle different data, if you want to, mainly when you're doing machine learning, you very often want to shuffle your data in order, for instance, to separate between a training data set and a test data set. That's exactly what we are going to do here. We are going to create a random matrix by using NumPy. If you want to do that without NumPy, that can take you a while with Python, but with NumPy you will see that that's quite easy. Okay, let's create a random matrix. What we are going to do here, we are going to use the function np_random. Essentially, what you have to do, you have to type np.random, and after that you have to specify if you want to random integers, or you have different possibilities. If you want to look at what you can do, you can just type, and you can have and type shift, and you will have the different opportunities that you can have with random. You can have randomize log normal, you can randomize multi-normal, multivariate normal, non-central. You can even randomize normal distribution. But here what we are going to do is to randomize integer. So, and again, inside this randomized integer, what we are going to do is, first of all, to have the low, the high, and the other options are optional. So the low we are going to use 0, the highest value gonna be 50, and you will see that the random matrix gonna raise any value between these two numbers. For instance, if you want a number between 1 and 150, let's execute. You will see that Python will raise you a number between 0 and 150. And after that, if you want to define it as a matrix, we are going to use the third argument, which is the size. Let's use the same size that we have defined here, 7, 3. Execute. Right here, you have just printed a matrix with values between 0 and 150 with a size of 7, 3, which means 7 rows and 3 columns. You can always have more information about argument just by typing Shift plus Tab. You will have all the information necessary that you need. Okay, that's all for this function random matrix. We are going to put an end about this first video. And in the second video, we are going to go more in depth concerning NumPy by covering the linear space function, how to implement operation, the two-dimension arrays, how to locate your numbers, how to filter, and how to set up a seed function advantage. See you guys.